15 years ago, I was working with IBM Watson and on some early stage experiments, and we were invited down to a squat close by that on South Bank where there was a crypto mine in action in the very earliest stages, and they were using machine learning to try to predict when and how to mine. And they were plugged into the grid illegally, and there was all kinds of vibrant action going on inside of that space. But written up on the wall was this word: if all else fails, use magic. And there was a sense in the room that that was what it was going to take for this thing to somehow turn out to be anything like what they imagined. Today we're going to be more like, if all else fails, use science. We're going to dig really directly into some of the things that are driving the transformations around AI, but also the bigger picture and context. 9 months ago, my AI startup, co-founded with Dr. Jennifer Barth, who you'll hear from later on the round table around responsible AI, was acquired by FSP. And we were kind of launched into this organization quite blind and without a lot of knowledge. The FSP was often described as one of the fastest moving and emerging consulting businesses you've never heard of. And I hadn't had a lot of involvement, and since we've been inside of there, we've been working towards a lot of the issues that I'm going to discuss with you today. And these are the challenges that we think are at the forefront of the leadership agenda, and the things that are most relevant to the transformations that are underway around the technology. So, when I move forward after my session, we're going to have our guests, and I just want us to give an initial warm welcome to them. So we'll be joined by one of the leading voices in the creative industries, and also one of the greatest advocates, frankly, for creative processes and the intellectual property that's generated in the UK for creativity, and that's Sir William Sargent. We'll also be joined by somebody that I would describe as a state security and cyber czar, one of the most impressive people that you can speak to about the intersections between cyber and AI in particular, and that's Gemma Ungoid Thomas. And finally, a spellbinding figure, frankly, and somebody that's a titan of industry and is one of the most vocal proponents for the UK on the global stage around competitiveness, Lord John Browne. So, here we go. Welcome to the age of intelligence. So, ages are typically defined by the material that drives value. So, the Iron Age, the Industrial Age. Here, the material is intelligence itself. And this isn't a story about the origin of AI, but it is a coming-of-age story, and I think we all love coming-of-age stories. AI has matured at what we would think of as biological warp speed. So, 13 years of maturity in 36 months. But it's entering what we would think of now as a real awkward teenage phase. And the reason I say that is because, it's half monster, half magic. It's all hormones. It's moody. It's full of tantrums, but also potential. And they grow up so fast, don't they? So I'm going to walk you through now 5 breakthroughs in AI that wouldn't have been possible even 6 months ago. The art of the possible. So frontier science and mathematics. So the early LLMs were really bad at math. I don't know if you had that experience, but good at language and bad at numbers, bad at symbolic systems. So GPT-3 accuracy on even 3-digit arithmetic was less than 25%. But now the math gap is closing really, really fast. So DeepThink went to the International Math Olympiad last year and got a silver. But it kind of cheated because it took 2.5 days to do the test when you're only allowed to do it within 4.5 hours. And a lot of that was because the mathematics had to be translated into code and be able to be understood. This year, the same model advanced, went to the Olympiad and won the gold medal. and that was matched by only 6 mathematicians in the world. So in 12 months, we saw this escalation, and it did it within the time frame of the expectations of the competition. So proofs developed in hours instead of days, and it's not just in mathematics, in theoretical physics. Professor Matthew Schwartz at Harvard ran an experiment to take on Opus 4.5 from Claude as a grad student and worked with it, and he was able to generate one of the most highly cited papers of the year in theoretical physics in 2 weeks, in what would have taken a year. And in that case, Professor Schwartz didn't touch a file directly. And these kinds of developments show us something quite interesting, and that is that if the IMO, the International Mathematics Olympiad, shows us that AIs are capable of taking the wicked problems on in mathematics, then we can extend this thinking to other domains and solutions and realize that the art of the possible, things that are impossible, can be made possible. It was impossible for AI to solve for those mathematical equations just 12 months ago, and now it's imminently possible. Where will it be 12 months from now? So we think about complex interconnected challenges like climate change or solving for hunger, and we know those are socioeconomic, wicked problems, and they can't be fixed by traditional linear engineering. We need these leaps in innovation. And once we start to see these solves come through, then it builds confidence, it builds trust, it builds belief in the systems. And I don't know if you saw the other day, but Amazon is spending $16 billion a month on AI. Alphabet's spending $14 billion a month on AI. Microsoft's spending $12 billion on AI. It's the equivalent of building a Channel tunnel every month. The entire spend on global hunger is $10 million a month. Billion, pardon me. All those numbers were billions. So, the question isn't really, should we be spending more on hunger? The question is, can we leverage that investment that's being made on AI to help stretch and extend the impact and the value of the investments that we're making on trying to solve a wicked problem like global hunger? And that's the kind of intersections I think we're going to start to see appear. Just as it was able to solve for that math wicked problem, we're going to start to see quite quickly here quite remarkable solutions to things that have been really sticky and difficult for us as human beings to solve. Second area, financial services and entrepreneurship. So we have precedent here. I was involved quite deeply in the early stages of machine learning and high-frequency trading algorithms and the transformation of the traditional brokerage models that ensued and the pressures that came out of that. We saw recently St. James Place here, one of the biggest wealth managers, lose 13% of its value in a day off a response from Haven, the launch of a US-based AI-enabled wealth manager. Now, the underlying fundamentals for St. James have never been stronger. It's a fantastically high-performing business at the moment. But what was happening is that markets were pricing future displacement, anticipating what it was going to look like. So in knowledge industries, we're starting to see AI losers emerge across sectors, typically perceived as middlemen, making use of the AI technology, which their clients are saying, well, we're just going to make use of that same technology ourselves and move that capability in-house. Why would we pay you to make use of the same sets of technologies that we already have available to ourselves? And that's leading to a conversation about what the winners look like. Now, the winners right now, are fundamentally on the supply side. So we see them in the backbone, the landlords, the data infrastructure, the platforms. That's the native stack of AI. That's the bubble and the conversation around the inflated value potentially of those organizations. But we're starting to see winners emerge on the demand side. And those are the ones who are managing to crack the IP dilemma. The question around what can we do with AI to incorporate into the way we work and our processes that leverages our expert knowledge and embeds it within the capabilities that we bring to bear around AI. And the best example of that we can see right now that's kind of really, really interesting, it's a sort of a child of Mustafa Suleyman, the CEO of AI for Microsoft. And that's the Artificial Capabilities Intelligence Challenge. That's a challenge that asks you, if we give an AI $100,000, can I get back $1 million? And it's completely autonomous challenge with no further interference. Simply supply the money to the AI agent or set of agents and allow it to try to turn that money over. That challenge is well underway now, and my latest sort of reflections on it are that it's going to be solved within probably 6 months. And when we see that kind of solution solved, some of the most successful ones have started paper product companies, built a whole bunch of educational videos, sold that externally, diversified portfolio of enterprises, a lot of digital enterprises, a lot of services. And the problem at the moment is the context window. The problem is that the AI can't stay focused long enough on the challenge. But that problem is quite quickly being overcome. We're seeing an S-curve, an exponential S-curve on that, a doubling of that context window even every 3 weeks at the moment. So, what's interesting about that is that, once the AI doesn't drift and doesn't lose focus, and there isn't really a time-bound scenario, then we're starting to see a different test from the Turing test. The Turing test was meant to test, and you saw that in that earlier video, whether the AI was intelligent. And what it meant by it was, can we not tell the difference in communication between an AI and a human being? But that's not really that relevant to us as human beings, because it's kind of like, what could we do with that if that was possible? Why would we want to create an AI that was indistinguishable from a human being? Instead, we focus on impact and purpose. You have a challenge, and you say, this is a complex challenge that we need the AI to be able to solve. And if it's able to bring together many different strands of ideas and nuance and context and so on to solve that problem over time, I want you to do 10 times my investment, that's the challenge, then that's the next generation of this test. And that's the new benchmark I think we're looking at. And as I say, I think that's going to be passed in the next 6 months. Let's look at healthcare. So really interesting from the Reasoning Machines Lab at Oxford. Fantastic study, best of its kind that I've seen. So, the latest vertical AI models around healthcare diagnosis are showing 95% accuracy. 95% accuracy across 1,300 different conditions. And the way that the accuracy is generated is by a full picture of the data being supplied. And then the diagnosis is conducted by the AI. As soon as you put those diagnoses in the hands of people, the AI accuracy falls to 35%. So that's when the human takes the package of data and tries to describe to the AI the symptoms, tries to describe to the AI the condition. At that point, you get distortion, you get lost information, you get all kinds of things. So what did we learn from that? We learned that we need these kind of direct data pipelines of the data straight into the AI, but that once the AI is able to make the diagnosis, that's the point at which the human gets into the loop and starts to re-engage with this information. And this is incredibly powerful for us because it kind of builds a roadmap for us to understand. And part of this is you need black boxes in the agents, and you need control towers, and you need mechanisms to be able to provide transparency and oversight and be able to catch things much quicker than we can currently. That's the kind of thing we're working on in FSP. That's the scaling challenge, right? We need to build a healthcare diagnosis system that's 95% reliable because it's already there and available to us. It's only about the design of the system itself that's restricting and constraining the outcomes. But the stakes couldn't be higher, de-risking life itself. Let's take a look at sports science. So, I'm a big NFL fan. NFL draft is tonight. For those of you who've been interested, I assume there's not many. It also starts at 1 a.m. Set your alarms. Yeah, the draft is so exciting for people that love the NFL because there's no better industry in the whole world at nurturing young talent. The NFL has always been the most brilliant organization at building and developing young talent. The pipeline, the scouting, and all of it's built upon the business models that drive these organizations forward. Last year, everybody said, AI was basically useless, was getting things wrong all the time, constantly making poor recommendations. Scouting networks absolutely rubbished. This year, Les Reed is the GM of the Super Bowl favorite. We just held it all. He was half joking, only half. He's talking about now they're looking to recruit a wide receiver. They looked at 240,000 wide receivers in the United States. Previously, their scouting would have been limited to 100 at most. In depth, how was this done? Computer vision. All the tapes, all the video, all of the content that's available, analyzing. We need a player with the following traits and attributes. That type of trait matching can be thought of at an HR level or in any organization when we talk about talent. We start really recognizing the value of AI in unearthing not just hidden gems and so on, but building this matching capacity between what we need and what we have available to us, and seeing things that would previously have been invisible. Last section, the autonomous vehicles. So here we have the art of the possible. And this is really one of the most interesting ones for all of us. I mean, you may have seen the Waymos around the streets of London now. By 2027, they're going to be on the road and they're going to be available to all of us. For any of you who've driven in them in San Francisco or in any of the other driverless cars, what's always quite remarkable about it is that it's not a singularity, it's a multiplicity. It's what we think of as stacked thinking. One of the problems that the driverless cars and autonomous vehicles got caught up in was theory. Got caught up in thought experiments. One of the most famous ones was the trolley problem. The driverless car is approaching, somebody walks across the intersection, it has to swerve out of the way, but if it swerves out of the way, it goes off a cliff. Is it going to take the driver off the cliff, or the passenger, or is it going to hit the pedestrian and kill them? Who should the driverless car save? Thought experiment. Turned out to be, extremely negative on the progression of the technology. What was actually going on was that the focus needed to be on the actual outcome we were trying to achieve, which was safety. And the reason that the Waymos are on the street now in London is because we have 170 million miles of data now from San Francisco, and the Waymo vehicles are 92% safer than vehicles driven by human beings. You have a 98% less chance of a fatality in a driverless car than you do in a car driven by a human being. That's whether you're a passenger, driver, whatever. Why is that going on? Some of the things turned out to be so simple. More than 60% of the accidents in San Francisco happened at intersections. And they happened because of driver error. People going in too late, people going in too early, people taking unnecessary risks behind the wheel. The driverless car never does that. It never makes a mistake at an intersection. And just with that, 60% of the accidents disappear. Those are the kind of things that we learn about stacking AIs and thinking about all the different ways in which we can use it that have been really, really ultra powerful. So I'm going to conclude now. How did all these game changers go from the impossible to the possible? There's a lot of things happening with the technology. Some of you may or may not be deeply involved in this. These are the spaces, again, that we're exploring in FSP. The vibe shift, the shift from prediction to reasoning, the flywheel between hardware and data that we're seeing emerge. These things are making a substantive difference to the capabilities of the technology, and many of them are leaps that are even more than the transformer architecture that arrived in 2022, but we're still treating it like it's the same old reptilian brain that we have to deal with. It's not really. It's incrementally changing over time. There are going to be limits, but we haven't anywhere near reached them yet. Inside the human being, the main idea right now for what human beings are going to do once this all plays out falls into typically two categories: orchestrators, directors, right? Or context gatherers. I don't really like either of those just quite, and I'm sure, there's room still to improve. The one that we're still looking and searching for is meaningful work. What does it actually mean to us? What would make us feel more human at work, not less? And we're struggling because we built a technocratic system that sort of expected people to behave a bit like machines, and now it turns out machines are better at doing that kind of behavior. But what about unleashing our humanity in a different way? Unresolved. Around the world, bodies versus brains, the Chinese are developing the robots, and the Americans are developing the models at the moment. There hasn't been really a coming together of those things in the way that we might expect. That's coming, though, in different forms. There's a weaponization of AI. There's a question around sustainability and the impact of AI on our planet, positive or negative. And there's an addressable market to be considered here. You know, is it the whole of the global economy? You're going to start betting 16 billion a month. I think you think that the market's pretty big. But all these things are unresolved. Come back to the idea of a teenager, you know, so what's our responsibility? If AI is a teenager, and this is a critical phase then, right? Because what comes next for a teenager, right? Leaving the nest. So if this is the window that we have, and we don't know how long it is, then our responsibilities are, you know, developing an environment, boundaries, values. It's a kind of ultimate responsibility. It's quite difficult. And so the question is not so much whether AI will grow up, it will, but it's what kind of actor will it be when it does. So we're standing on the shoulders of giants. What are we going to build into the next age? You're going to hear a lot more about that today. If my role here has been to frame the stakes, then the next voice is someone who has spent a lifetime shaping how technology tells stories, reaches audiences, reaches you, you know, here and here, right? And has had a really profound influence on the world around us. Multiple Academy Award winner, multiple BAFTA winner, titan of the creative industries, Sir William Sargent.